Exploring space is about defining space, forcing you to rethink your notions of big and small. On the scale of a grain of sand, each and every granule appears unique. But as you drive Deep Space Explorer outward from Earth, your frame of reference shifts. At this scale, the most massive mountains are but blemishes on the speck of sand that is the Earth, itself just a granule among uncounted others, on an island beach amidst innumerable companions, each surrounded by the oceans of nothing that characterize most of today's universe. It doesn't take much to feel small. Flying just a few hundred kilometers above your homeworld, you have to scan very closely to detect any sign of human presence. Shift sensors around, and you may detect hundreds of artificial satellites, like these global positioning satellites. Or even the human-rated satellite called Alpha, the International Space Station. All these track around in a variety of low Earth orbits, each completing one cycle in no more than a few hours. Jump now about 100 times the height of low Earth orbit, to that special place in space where the big communication satellites live. Bounce Deep Space Explorer again, this time to about 1,000 times the altitude of the space station. You are out nearly 400,000 kilometers, in orbit about the Moon, Earth's only natural partner in its annual dance around the Sun. The Moon is stamped with the furthest footsteps of humankind. Pulse Explorer once again. And you're 650 million kilometers from the Earth, entering the domain of the outer planets, the gas giants Jupiter, Saturn, Uranus, and Neptune. The distances between them are so large that common units, such as kilometers, are cumbersome and inconvenient. Astronomers instead speak in astronomical units, the average distance between the Sun and Earth, roughly 150 million kilometers. Jupiter lies 5 astronomical units from the Sun. Spring Deep Space Explorer 10,000 times further, call it 50,000 AU, and you've reached the edges of the Oort cloud, a spherical shell of frozen conglomerations of dust, which long ago congealed out of the cloud that formed the solar system. Occasionally, one of these objects will be pulled astray and venture in towards the Sun, where it will appear as a bright comet in the skies of Earth. The next jump requires yet a new unit of measurement. Even the nearest stars are so far away that it takes the light of the Sun, or a signal from an Earth-based transmitter, 4 years to get here. A light year is about 63,000 astronomical units. That's 9.46 times 10 to the 12th kilometers, if you must know. But even if you vault Deep Space Explorer 1,000 light-years out from the Sun, you still have covered less than 1/100th of the distance across your home galaxy, the Milky Way. Where's the human origin point from here? Look about halfway out, in one of those 75,000 light-year long spiral arms. The Sun will be an inconspicuous yellow star, orbiting with its companions, the massive black hole believed to lie at the galaxy's center, once every few 100 million years. But this is just the beginning of your universe.
We're moving around the Sun at 30 kilometers per second. The Sun is moving around our galaxy at 220 kilometers per second, and our whole galaxy is going somewhere at 600 kilometers per second.
Galaxies crave the company of other galaxies. They cluster together, thousands of galaxies like your Milky Way, extending over millions of light years. Galaxies, groups, and clusters tend to form into long strands, called filaments, threading hundreds of millions of light years across eternity. This meshwork of filaments make up the superclusters, the largest structural element known, a web of pinprick galaxies, permeating the void. Here, hundreds of millions of light years from the Sun, the Milky Way is just one of tens of thousands of galaxies. But even this rich filigree that ornaments the universe is but a tiny percentage of all things ever created.